Hello, everyone, and welcome to our event on smart and sustainable urban mobility. My name is Lucrezia Morgante, and I'm working as a trainee at the Helsinki Institute of Urban and Regional Studies, Urbaria, which is part of the university, and it's the university network for all urban researchers, representing more than 20 different disciplines. Today's event centers around two insightful presentations by postdoctoral researchers. This will be followed by a panel discussion during which experts will share their diverse viewpoints on the topic of smart and sustainable mobility. The main question that will be discussed during the event is whether novel technologies such as machine learning and virtual reality can help us make urban travels more sustainable. Through the insight of our experts, we will delve into whether digital innovations can reduce the environmental impact of urban travel while enhancing the health and well-being of city dwellers. Before introducing the researchers, I would like to start to discuss the Postdoc forum they are part of. The Postdoc forum project has aimed to find early career researchers to work on issues of particular importance for the city of Helsinki, Espoo, and Vantaa, which have given substantial funding to the program. The objective has been to bridge the gap between cities' needs and research-based knowledge that can help address them. The project began in 2018 and will continue until the end of this year. Over the past 8 years, several researchers have been part of the forum, exploring urban issues from a wide range of angles. Urban studies have provided a common ground for many disciplines, from anthropology, sociology, and economics, to computer sciences, artificial intelligence, architecture, and environmental sciences. Alongside the postdoctoral researchers, a number of professors from the University of Helsinki and Aalto University have played a key role in the project as supervisors. They have supported the program by sharing their expertise and offering valuable multidisciplinary perspective on urban studies. Their involvement has been essential in connecting academic knowledge with the real-world challenges that the cities are facing. Many of the professors who took part in the program are still working on projects related to the Helsinki metropolitan area, and in some cases have continued their collaboration with the postdocs. As you can see in the slide, the project has also contributed to building a strong network of institutions, consisting of universities and think tanks, both in Finland and abroad. After completing the postdoc project, some researchers have continued to work in the Helsinki metropolitan area, while others have moved to other places and are now applying their expertise in new geographical contexts. This has helped to create a vibrant research community that extends across national borders. So far, 17 postdoctoral researchers have participated to the program, and today we have the pleasure to hear from two of them, who are currently working at the University of Helsinki. The first postdoctoral researcher I want to invite on the stage is Bochenina. She will be presenting her work on sustainable ride pooling with reinforcement learning at scale, using a case study from the Helsinki city area. Welcome, Klavdiia.
Okay, good afternoon, dear colleagues. My name is Klavdiia, and I'm working in Spatiotemporal data analysis group, headed by Professor Laura Ruotsalainen, who will be later participating in our panel discussion. Today, I will present my work, which is entitled Sustainable Ride Pooling with Reinforcement Learning at Scale, applied to Helsinki city area. I will give brief introduction to the problem, to the, let's say, mathematical statement as well as societal impact, and we will discuss three key components with which we were working, because reinforcement learning is a special paradigm when you need not only to develop the algorithm, but when you need to train this algorithm in a special kind of virtual environment. In our case, this is traffic simulation of Helsinki. Then I will talk a little bit about the algorithm, the peculiarities, and a little bit more about scalability, because reinforcement learning is hard to train, and we were also exploiting supercomputer located in Finland to scale this up. All of you know that greenhouse gas emissions cause global climate change and can harm both human communities and wildlife species. Basically, global greenhouse gas emissions grew by 25% in 15 years. More interestingly, a quarter of all emissions come from road transportation. And as you can see in the right figure, transport was the only sector with drastic growth of emissions in the past 30 years, more than 30% growth. Tackling these challenges, the city of Helsinki has invented so-called action plan, which goal is to make city of Helsinki carbon neutral by 2035. And still, you can see in the picture that private cars are the major contributor to all of the emissions in Helsinki city area. What we can do with that? Actually, if we want to reduce the emissions from cars, we have different perspectives. First, we can think how to reduce it at the level of a single vehicle. It may be, for example, inventing new, more efficient fuels like hybrid fuels, promoting electric cars, or for automated vehicles, developing some eco-driving strategies. When we look from the perspective of city stakeholders and city infrastructure, it may be some inventions related to smart city concepts, when, for example, we can make traffic signal control systems more intelligent by equipping them with different sensors and cameras and making traffic signal schemes react to traffic flows within the city. We can optimize, for example, parking fees and pricing and car-free locations within the city. So this is about the infrastructure. My work lays in between because I work at the level of managing the fleet of cars. The examples can be route planning, because you have a fleet of cars and you need to co-plan the route of all the cars to reduce traffic jams, for example, because traffic jams also contribute to CO2 emissions. My work mostly oriented to this challenge of increasing the average occupancy of cars. As you can see here, private car fleet is heavily underutilized, with average occupancy less than 2 people per car. Let's talk about the problem statement of sustainable ride pooling. Basically, by ride pooling, we mean a situation when we need to perform a management of a fleet of taxis, when passengers can share the taxis. For example, in this figure, you can see that we have 2 taxis, and we have 3 passengers. And in case if passengers cannot share the ride, one passenger needs to wait until 2 taxis will serve the other passengers, while in a ride pooling setting, taxi 1 can pick up passenger 1, then pick up passenger 2, then drop off passenger 2, and then drop off passenger 1. And in this case, you can also notice that this passenger do not do any long detours, any excessive distances. That is, we can use just one car to serve both passengers, and then we can reduce CO2 emissions. This problem is actually interesting because it is multi-stage, and there are a lot of problem statements in the real world. For example, we have step of matching or assignment. That is when we need to decide which taxi should serve which passengers. Then we have a problem of pricing, because in a real-world taxi system, usually taxi drivers can decline passenger requests, and vice versa, passengers can decline requests of drivers. Third part is routing. It is the stage when we already know the origins and destinations, but we need to find the optimal route through all these points. Finally, we may have a problem of repositioning, because we may predict the areas in the city with a high demand, let's say in the next hours, and we may reschedule some of the cars, of the free cars, for anticipated demand, thus reducing waiting times. My work mostly related to matching step, because we consider the case when we have automated taxis or robot taxis, so they cannot decline the requests, and we can set the prices. And we perform routing with some standard algorithm, and we do not consider the problem of repositioning. One of the specifics of our problem is that we want to work in real-time conditions, so we don't know the sequence of passenger requests over time, and our system should react to newly arriving requests. The interesting part here is also how to measure the efficiency of this kind of system, because we have different actors in a city which have different goals, basically. For passengers, of course, passengers want to arrive to their destination on time, so to measure passenger satisfaction, we can, for example, calculate average waiting time of the passengers in a system, or the metric more specific to ride pooling, this is average detour time or distance. Detour is an excessive time or distance which is added due to invention of ride pooling, because if there are more than one person in a car, the overall route may be longer. Second type of metrics are taxi fleet usage metrics, because we want to set the occupancy of the cars higher, and we can measure it by the percentage of idle time or distance. And one novel thing that we studied there, it is sustainability metrics of the taxi fleet, because previous works did not consider the sustainability metrics explicitly. In principle, this is related to the fact that basically designers of ride-pooling algorithms, they do not calculate emissions explicitly, because to calculate emissions from the moving cars, you need to have some micro-simulation models, because emissions depend on velocity, acceleration, and so on. And in this study, we did this with this level of granularity. Let's now go further to the key parts of the problem. We want not only to develop new algorithm, but we also want to apply it to solve some real-world problems for the city of Helsinki, to contribute to this carbon neutral action plan. And this is why we can address this question: how the invention of innovative transportation means, in our case, ride pooling, will help to reduce CO2 emissions in Helsinki city area. This problem has three different parts. First part, which I called simulate, is related to the fact that we use reinforcement learning. In reinforcement learning, we need to train the agent. Let's think of this agent as of dispatcher of the taxi system. And the agent in reinforcement learning is trained by the process of trial and error. So you have agent, you have some decision model inside this agent, and you let this agent act in some simulated environment and give him some rewards and punishments for good actions and bad actions. And the goal, in a mathematical sense, is to optimize long-term reward of these agents, let's say over the whole simulation day or something like that. And because we use this paradigm of artificial intelligence, our first problem is how to create accurate and representative virtual environment to train our agents. Because if we want agent work in Helsinki city, of course, we need some simulation which resembles traffic flows like they are in the Helsinki city, and thus solve this real-to-sim challenge. A second part is training of reinforcement learning algorithm itself in this environment that we created before. And the third part is related to computational efficiency, because training reinforcement learning models, even for small areas and small number of agents, is time-consuming, because it is trial and error process, and usually you need to iterate over dozens of thousands of trials, and repeat the process also for dozens of thousands of episodes. So third part is how to assess the impact of right pooling for sufficiently large areas. Let's move to our first problem, real-to-sim. We started from creation of microsimulation traffic model of Helsinki city area. We considered the area like you see in this picture, and we used two main sources of data for this. First source of data was provided by helmet model developed by HSL. This is a mobility model for the whole Finland, and it gives the data in the form of what is called origin-destination matrix. Imagine if all Finland would be divided into some cells, and we know the number of cars from each traveling from each cell to each other cell in different hours and in different days of week. We started from additional algorithm which made a reduction of this data from the whole Finland to the area of interest, Helsinki. And then we used the second source of data. In this figure, you can see these green markers. It is actually traffic counting stations. They are located at the major roads in Helsinki city area, and they measure the flows of transport in different directions with pretty high granularity, I guess up to 15 minutes. So what we did, we used helmet data as an input, and then we calibrated our model using this more accurate data for Helsinki city area, and we arrive at these values of the quality of our model, of our environment. These values in the area of traffic simulation can be considered as good and realistic enough to go further. Another interesting insight was related to measurement of sustainability. In this project, we work in collaboration with atmospheric scientists from Professor Lena Järvi's group, and we discovered that actually default models of measuring the emissions, we implemented our algorithm in Sumo simulation software, and it has some set of default models to measure the emissions. So basically, we discovered that these default models, they underestimate the emissions heavily when compared to the models which was tailored and calibrated for Helsinki city area. So we ended up incorporating this more accurate model to Sumo, and we work with model of our colleagues for the emissions. This is the simple scheme of our algorithm, I don't want to go in so much technical details, but I would like to say that we decided to combine two approaches to solving right Pooling matching problem, which already existed in the literature. Historically, matching was solved by simple heuristic algorithms because they are fast. The example of heuristic is assign the passenger to the closest taxi in terms of time or distance, or something like that. Some simple interpretable techniques. Of course, they are not optimal. And the next generation was dispatching with reinforcement learning, when you have some neural network which decides which passenger to match with which taxi. The disadvantage of these methods, also they provide better solution than heuristic. They also very time consuming, because if you think that you want to train something for 10 taxi and 15 passengers, it works okay. But if you want to scale up to thousands of taxis and passengers, the size of state and action space grows basically exponentially, and it becomes untractable. So in our approach, we decide to do like that. We still perform matching with heuristic algorithm, but now we introduce some parameters of dispatching, and then we tune the parameters of dispatching heuristic with reinforcement learning. Thus, it combines flexibility of heuristic approach and also the power of reinforcement learning. Some examples of our results. In this case, we considered this three-component reward. We have two components related to passenger satisfaction and one component related to sustainability. For passenger satisfaction, we calculated time of waiting pickup and traveling time, and we calculated different pollutants for sustainability. This is how the reward looks for one run of the algorithm. It is a little bit less than an hour. We performed also some normalizing of reward, because you can notice that all these things are in different units, and it was a separate problem how to make them comparable. Also, we have one part of the overall pipeline which allows to introduce the importance of different components for the user or stakeholder. In this picture, for example, emissions have half of the importance for the overall reward. Emissions is here. And passenger satisfaction is another half. The example of the results which we can provide with this system is on the right plot. What we have here, bars are different components of rewards, because we saw already that basically we need to find a balance between different components of rewards, because if we increase one of the components, the other one will be most likely decrease. Blue one is waiting time, orange one is traveling time, green one, oh, sorry, too much. So green one are emissions. And let's consider three cases. This is the case when we don't have ride pooling, when all the taxis serve only one passenger. In this case, we have the best traveling time, of course, because there are no detours. But you can see that in this case, waiting time decreases significantly. It is almost 30% lower than in the ideal case. This means that without ride pooling, passengers will wait for enormous time. This is another borderline case when ride pooling is used for all of the trips. And here you can see that waiting time indeed is the best, but we have a significant reduction in the traveling time. And this is the example of the results by our algorithm. You can see that it achieved best values for emissions. Of course, it achieved it by compromising two other goals of passenger satisfaction, but you can see that the decrease does not increase like 10% here, so it may be a good balance between different objectives. Finally, a few words about computational efficiency. To get the results that I showed on the last slide, for the area, let's say, of the size like one red rectangle here, we need probably several days of calculations. What if we want to have the results for the whole Helsinki? Here we can exploit and combine basically two different approaches. First of all, now with our colleagues, we are working on the method which will allow us to get the approximation for the whole Helsinki if we have the results by reinforcement learning for several representative areas within the city. This is first approach. In this case, we can just use massive parallel computations to run several instances, several independent instances, and that get the result in a reasonable time. Finally, we can also make more sophisticated parallel algorithms. We already tried to parallelize our reinforcement learning approach using a thing which is called vectorized environments. And we made some tests at Lumi supercomputer. You can see that basically it scales not so good. The parallel efficiency is up to 35%, but this is because we have a lot of sequential code. Basically, the simulation part, like sumo part, when we simulate the movement of the vehicles, it cannot be parallelized at the moment. But reinforcement learning part scaled quite good. It corresponds well to the theoretical predictions because we also trained let's say this is the model which shows how the times of training will decrease with the increase of the number of cores that we exploit in the parallel system. So now we are planning to combine these both approaches to tackle this problem of estimation of impact at the level of the whole city. So, summarizing, maybe the major output from my talk is that if you want to apply reinforcement learning for large-scale problems, you always need three components. First component is realistic environment, so you need to know how to use real-world data. Second is algorithm itself, and third is a computational part of everything, because we need to get the results in a reasonable time. And there are a lot of interesting problems, basically because the process of creation of reinforcement learning problem statement is also the object of art. You can select different state and action spaces with different expressiveness. And you can think of different kind of architectures of the underlying networks and so on. And of course, each decision also influences how long it will be trained after all. So it is interesting thing how to find the balance between how good your final solution will be and which advantage you can actually get and how long it will be trained, and also how complicated will be your solution from the point of view of implementation, because sometimes simpler solutions, they are much better for real-world deployment if you want to actually put your algorithm somewhere to work. So, as I said, we are now planning to perform city-wide scenarios using the approach that I shown. And the next challenge that we are already predicting is sim-to-real challenge, because even if we have really, really good algorithm, if we want the real robotaxis in Helsinki be operating using our algorithm, we will face this challenge, which means that if you trained your model in a simulated environment, when you try to deploy the results in the real world, you will tackle new challenges because there will be unpredictable changes. There will be some subtle changes that you did not put in your simulated world, and so on. So this is also the thing that is better to think of when you develop applied algorithms. Thanks for your attention. That was it.
Thanks, Klavdiia, for your presentation. And I would like to leave some time to see if there are any questions from the audience.
Thanks for the presentation. Can I ask, if, say, 3 years from now, a big part of the taxis will be electric cars, what difference will it make from the viewpoint of your research? Thanks.
If there will be electric cars, I think it is an interesting question because from the point of view of these models, electric cars do not produce emissions. But then you also need to account for the cost of producing the electricity for the electric cars and cost of production of electric cars themselves. So I guess it may be some other models which accounts for the whole cycle with the electricity.
First of all, thank you very much for the presentation. It was very interesting and very insightful into kind of the individual, like the non-scheduled mobility kind of, the topic of non-scheduled mobility compared to like public transportation and things. But obviously you're testing this in Helsinki in like a very urban environment, but what do you think is how feasible is it to scale to either a regional level or to maybe a more rural context? So, because obviously those areas are a bit harder to serve with typical fixed route public transportation. So this could have a lot of good implications for more rural areas where those services aren't as feasible.
Yeah, basically there are two answers to your question. First, for the area of restricted size, it makes maybe no difference for us which area to select, because even Sumo, it has, let's say, the way to upload any map when you give just geo coordinates of it, and we'll also upload the road infrastructure, even traffic light signaling schemes. So with some manual correction after all, this may work with any region. The other thing is when you want to simulate, let's say, whole Finland at once and to optimize everything. For this, I think micro-simulation models will not be suitable because they are too heavy computationally. Imagine, basically, they simulate the movement of every single car, even like like when car got stuck or something like that. But I think in this case, the switch from micro-simulation model to meso models can help, because there are also a set of traffic models which work let's say, closer, which work on the level of roads. And if you think of a road and some fluid moving through the road, like something like that, this may help, because to my experience, they are more than 10 times faster than micro models. But also, it is interesting thing for rural areas, because it may be, let's say, some vehicles with capacity larger than, like some small robobuses or something like that. So it would be interesting also to play with different type of vehicles.
Well, if there are no other questions, thanks, Klavdiia. And we can move on with the next presentation. I would like to invite to the stage Silviya Korpilo. Silviya is currently working on the Green Travel project, and today she will present how virtual reality can be used to measure the health and well-being effects of greenery during the active mobility. Welcome.
Thank you. All right, good afternoon, everyone. Yes, my name is Silviya Korpilo. I'm a postdoctoral researcher at the Digital Geography Lab and also an Urbaria postdoctoral researcher. And I'm very excited to present for the first time today something about our virtual reality cycling experiments and the process of developing those experiments. We use these virtual reality cycling experiments to study health and well-being effects of greenery during active mobility. So first of all, I would like to make clear that this is not only my work, so this is the work of a larger team. We are quite many at the Digital Geography Lab, and this is just our green travel team, which is part of this lab. So all of these people that you see, people and other species that you see at this slide, are actually very talented researchers that have contributed directly and indirectly to this project. However, the ones in red, highlighted in red, are the ones that have been running the experiment, so you're very welcome to go up to them and ask them any questions if you have. I also want to point out two people in the audience. So first is Professor Tuuli Toivonen. Tuuli, can you please raise your hand? So she's our project leader as well as our group leader. So if you have any questions about the project, you can go and talk to her. And then we also have Karanatan Ravandran. So he's here, we call him so he's our VR expert. So he's the one who has been responsible for the technical development. So if you have any technical questions, you can go to please go and discuss with So to situate this study a little bit, I'm going to start with a little anecdote. So imagine it's an early morning, you're going to work, you're cycling to work, and on the way to work you have to go to the shop to get some food, or you have to go to a cafe to pick up a coffee on the way. So what we're really interested in is how the different environments you're exposed to on the way while you're cycling, how they affect health and well-being. And actually, surprisingly, there is very limited evidence about this. And although the field is fastly growing, there is many more studies about this. We actually really know very little about the actual mechanism of how different types of greenery or the level of greenery or phenological changes like seasonality, how they will affect this. And the reason for this is that most of the nature health research is really coming from a residential-based perspective, which means that how many green spaces people have in their neighborhoods, how accessible they are, how big they are, what is their quality, or a recreational use perspective, so how nature affects us when we're out there, when we are recreating, when we're exercising, and so on. But actually, during our everyday travels, especially when we talk about active mobility, this connection to nature is very different. It's very unique because it's it's very unintentional. We have very unconscious way of connecting to nature. Also, the stimuli is very fastly changing. So we know very little of how this short and very temporary exposure affects our health and well-being. Do we have accumulating effects and so on? So on the quest to answer these questions, in the Green Travel project, which is an ERC-funded project that started already almost 2 years ago, we have very different ways of studying this. I'm not going to go through this, but we use a wide variety of methods, using big data, doing modeling, using street view images, and so on to really understand this. But today I'm going to focus on this first work package, which is that understanding people's experiences and well-being impacts. So to answer the question, how do greenery and seasonality affect travel experience and well-being? Generally, you can do that in two ways. So when we talk about experimental research, so I'm not talking about associations or correlations or large populational studies. I'm talking about studying causes and effect. So you usually can do in situ experiments or real-world experiments where you will follow participants in their everyday natural behavior. or you can do laboratory experiments or ex situ experiments. So we're doing both of these, but actually we're running the ex situ laboratory experiments, so I'm going to show you some of these. Maybe important questions. I wanted to put this slide here because I realized that not many people actually know about using, you're probably aware of virtual reality, but not really of how virtual reality is used in experimental research. So the first question is, why virtual reality? You can do that in many ways. And I'm going to share some of the opportunities it brings. And I'm going to start with the more obvious ones, the things that you may already know, I've heard about. So virtual reality, of course, provides more realistic and immersive experience compared to traditional photo or video methods. It also provides opportunities for controlled laboratory settings. So for example, if you're studying greenery, you're able to control what kind of species you put, how much you put, in what ways and where. It's also very useful in terms of urban greening interventions. So if you are, for example, want to study planting new vegetation, it takes a lot of years for the vegetation to grow to be able to do before and after effects. In these ways, we can actually simulate that and study this in a faster way. Also, as you may already know, virtual reality provides nature experiences to people with otherwise limited access. It has been studied more and more nature exposure, for example, in therapy or in elderly homes or with other people who have different kinds of either physical or mental disabilities. So it has an opportunity for inclusivity, which is not probably that applied yet. But less known is that virtual reality is very, very effective tool to induce emotions. They're a lot of reviews nowadays that actually show that it can be as effective as a real world situation, and even in some cases more. So it's an emotional tool. And also, research has shown that immersive virtual nature can promote nature connectedness. So this is also something new and exciting. However, it has various challenges. And first of all, again, the more obvious ones. I always start my talks with that virtual nature will never actually replace real nature. That's not the aim. Virtual nature is a tool. It's a tool to provide some kind of immersive experience, to provide the feeling of nature. But we all know that nature is more of the sum of its parts. It's very complex. So you can never portray this complexity. Also, there is limits of sensory input. So virtual reality is quite visual, of course. You can have auditory stimuli. New research and new advancement add also factors, so smells to the research, but still it's not really close yet to multisensory experiences in real environments. We have the issue of cyber sickness. This is quite commonly reported. It means that you have a feeling, you're feeling a little bit unwell. However, there are actually quite a few studies that show how to actually overcome this. So it's usually related to desynchronization of different stimuli, to the quality of the environment, also individual factors. You have tried it before. Women are more prone to cyber sickness and so on and so on. But for example, in our case, we have taken serious steps to reduce that, and at the end, none of our experience really experienced cyber sickness. Also, it has technical and resource requirements, so you need skills. And this is really important because in urban planning, in our field of urban planning or human-nature interactions, these skills are usually not there. So you either have to have teams to work with you or actually get a company to provide these. And it's, of course, technically and resource requiring, so the equipment can be quite expensive, and it's also very fastly changing, so you have to keep up. But less known also, for example, it's about the challenges of how actually how virtual reality provides ecological validity. And here I'm not talking about if the environment you are creating looks like nature. Ecological validity in experimental research talks about it actually means if scenario A is likely to be like scenario B. So scenario A is experimental situation created for the study, is sufficiently like or unlike the real-world scenario it aims to model. And that actually refers to both things. So it refers to the environment, so the actual structure of the environment, but it also refers to the behavior. And this is something that we often don't really think about. So we have limited knowledge on behavior and psychological responses in dual realities. So the choices we made in the virtual reality, are they similar to the choices we make in real-world situation? And the concept of dual reality is actually not new. It's something that has been out there since we have immersive cinemas. For example, an example of dual reality, you are in a 3D cinema, experience very immersive audio-visual stimuli, and you are emotionally engaged, you have sense of presence, but then you know, at the end, you have the top-down knowledge that this is not real. Still, you experience this situation, it affects you. Another example of dual reality is pretend play in children. So children could pretend that they play. It's an alternate reality. They will behave like in this other reality, but still they know that this is not real. In virtual reality, since it's even more immersed, we could argue that there is more and more of these cognitive mechanisms of how they actually perceive this as a dual realities that we make decisions. And these decisions are often conscious and unconscious. There's not only something that we make choices about, but there's something that we unconsciously do in the virtual world. And here, final thing is that this is really has to be put in the context of contextual realism. Contextual realism means that, simply put, some things feel more real in certain contexts. So if you are exposed to a virtual reality of a traffic incident, and you have experienced traffic incident before, you're more likely to experience high contextual reality. So you're more likely to be more engaged, and you're more likely to be more affected. So this is important when we create our experiments. So in the journey, once we have considered all these advantages and disadvantages, our journey began with a very systematic and long and a lot of effort in the development process that took about 1.5 years, in which we had multiple iterations as well as multiple inputs, because this is a transdisciplinary project. So we started with planning and system design. Then we have an expert workshop from where we had international experts from different fields, including health and ecology and transportation studies and VR experts and so on. When they would develop the system, then we had a workshop with urban planners. We'll be talking with City of Helsinki about how we can rate these environments better and how this is useful for them. Then we create the environments, and then we have internal testing. Then we do another iteration. Then we get feedback again from all of the experts and planners that we have been engaging with. Then we do 100 more iterations. Then we do a user testing, final user testing, after we do another iteration. And then we started the data collection in February. The data collection ended last week, so I have no results to show you yet. But I will show you how it looks like. And at the end, we had 150 participants. So we created that very complex system network of where everything is synchronized, the software and the hardware, everything that people experience, everything is synchronized. We created our environments in the Unreal game engines. And then we had the bike, as you can see here, and the Vario data sets, and we had many other things. We had some physiological measurements as well. So in this complex system, where it had many different components, at the end we also experienced that the more the system becomes complex, the more it is prone, of course, to the domino effect of when something doesn't work, then it affects all other components. But luckily we were able to deal with this during our experiments. And this is our experimental protocol. So it's a randomized control trial. This is a very standard way of doing research that looks at, for example, how certain environments can be pleasant or restorative, how they can affect emotion. So we did different kinds of psychological and physiological measurements. So how it will work is that people will come in, they'll watch the video of what the different steps, they'll sign the informed consent, then we'll have a pre-test questionnaire, we learn about their individual variables, their age, gender, their house. Also, we have the so-called psychological baseline. So how people would come in before our experiment is very important. So when you come in, are you stressed? Are you nervous? What is your emotional states? We measure this through psychological scales like recreation outcome scale, PANAS, subjective vitality scale, and so on. Then we'll put our equipment. So the one that let's show, the one that, showing. I don't think that works. But anyway, the one that is the screen conductance is the one that we measure arousal of the sympathetic nervous system. So it's basically stress through electrodermal activity. So people will carry this throughout their hand and will measure their stress level throughout the whole experiment. After our sitting baseline that they are calm, we'll also do a VR baseline, which means that they will be cycling through an environment for a very, very abstract neutral environment for some time, to get used to the equipment, but also to remove the wow effect, because VR can have a wow effect for people who never experienced it. This can actually affect our measurements. And then we have a stress period, which is quite common kind of established way of doing this kind of experiments. This is something that people didn't like because it's a mental arithmetic test using backward spanning. So people had to subtract from 1017 backwards for a very limited time. And if they get it wrong, they have to start from the beginning. It's a mental cognitive load, so it stimulates, for example, the same that if you go to work, if your whole day at work, you're cognitively tired, but it's also social stress because people don't like to get things wrong, and they feel embarrassed if they can't complete the task. After that, we'll do a randomization, so we use the in-between subject designs, which means that each subject or each participant is experiencing just one environment. And this is called a treatment period. So you get stressed, and then you get treated with specific exposure. And in this case, we had this audio-visual computer-generated virtual reality simulations. And we have different scenarios, so I'll show them. During that time, we also took eye tracking and facial expressions to see how emotionally people would feel. And after that, after they bike for 8 minutes, they'll come down off the bike, and then they'll follow the post-test questionnaire in which we use the same scales and some additional information on their experiences. This is how our setup was looking like. So we have different kinds of hardware to be using and different kinds of, for example, here are the physiological measurements. So for example, our EDA measurements, so electrodermal activity, which shows us the stress. So you can see in the dark blocks, these are the different blocks that people of different periods that we'll see what their stress levels are. But we're also able to see specific environmental stimuli like the bird songs. So we know in real time when people have experienced or heard a bird song, and then we know if we have a skin conductance response, did it really affect them? We also, we get eye tracking data from the Vario headset. And we're not really interested exactly where people are, but either we use different as a physiological marker. So for example, we're interested in pupil diameter, which is also a marker of stress or your emotional state and in general. And then we also have cameras, so we had facial expressions, so we use videos of people as a validation of the psychological scale. So we have a psychological scale, so we study emotional state. We also have this emotional facial expression showing emotional recognition. So we use a face reader algorithm to actually show what is the probability, most probable emotion that you experienced. And maybe here to mention is that we also had a fan because we try to have this multisensory experience more. So at the end, we created this 2 kilometers of a straight street. People would be put in the start of the street in the same location, and then at the end, they will finish at the same location. And we had the same task like my anecdote at the beginning. So They'll ask to go to the shop, to imagine it's an early morning, they're cycling to work, and they have to reach the supermarket, so they have to buy food. So their task is to get to the food. So this is a simulation of the real scenario where there will be like active mobility. We also controlled, so the street was, this top-down view of the street shows that it was straight, but however, there will be some crossings. And what we will see, for example, in the experiments, that many people will actually slow down or look around in the closest, although they know that it's a safe environment and they know. So this is what we're talking about, unconscious behavior in contextual realism. So they will do these certain things they will do in real life. Then the environment was safe. There were no people, no animals, and no moving cars. So maybe the first thing here is for everyone is like, well, this is not real. And of course, there are many decisions to be taken into consideration. And why we decided to do is first, again, contextual realism. So if we have this, for example, in any other cities, like in London or Lucrezia cities, that maybe look really, really weird. But to be honest, sometimes in Helsinki or in Finland, you can ride in the morning and for 8 minutes and see no one. And that's really something that may be not that odd. But also there is this other point of, for example, if you put people in this, but they do not behave like real people, then you reduce the contextual realism. So it becomes actually counterintuitive or counterproductive for us. So I have a little views of these environments, how they actually looked like, and then we have a little demonstrations. So as I said, first we had 151 participants, and all of them went through this neutral environment. They all cycled to this very abstract, I'm not sure if some said it's boring, some said that it's really pleasant. And after that, the randomization became, so each one of them will be randomized to one of these other ones. We had 4 scenarios, an urban, a low diversity, high diversity, and a winter one. All of these environments have absolutely the same built infrastructure. So we did not change the built infrastructure. What we changed was the greenery. What we changed was the seasonal conditions. We chose the city to be constructed as a city that is familiar, but you can't recognize it. So it's not really a replication of Helsinki, but it doesn't seem odd. It feels like a city. Then we had also some of these small elements like traffic lights and buses that are very local to increase this contextual validity. And then the difference between the low and high diversity, for example, is not so much about biodiversity, but it's more like structural diversity. So we add different levels of vegetation. We have pollinating features. We have, for example, here now you can see that we have green walls and vertical vegetation. We'll have in the high diversity more species of birds. You will be exposed to more birds and so on. And the winter is a replication of that. And as you can see, the vegetation is quite new. So it's newly grown. So idea is that this is for urban planning. So if you are to plant new vegetation, in what ways can you do that to be beneficial? And now I'll ask Mikko to come and do a small demonstration for us, because the screens are quite small. So we're hoping to show you how this can work on a bigger screen. So if we play, of course, the nicest one, the high diversity. Okay, so I'll tell you when we can start. And yeah, you can start now. So this is how, I'm not sure if you can hear anything. Can you? No? Usually there is sounds. So the sounds are, we have here. But you can't see the background traffic. Yeah. So this is an example of the green walls. Okay. Okay, that's enough. Okay, thank you, Mikko. You can stop. And usually, you can look around. So Mikko didn't look around at this point, but you can look around. Thank you so much. I can help you. You can look around, and once you look around, you will see that there is, for example, different species on that side and so on. So people can look around, but they could not turn because we didn't want them to fall from the bike. Thank you so much. That was really fun. Maybe someone else can taste later. I'm going to finish this with some consideration for future research using VR. And I think this is a good kind of transition for the talk. So maybe the main thing to remember here is that virtual reality is not purely technology, it's a psychological tool. It should be treated as a psychological tool. And this is really important if you are to use experimental research. Also, VR may revolutionize emotion elicitation methods in laboratory settings and open novel directions for affective computing research. This is a very new field, so it's very exciting to see what it can do. However, there are ethical considerations, and they're different. So they have to be carefully considered and adjusted to the unique cognitive mechanisms of dual realities and virtual VR experiences. So we need more research in that field. And also that ecological validity of VR experiments can be increased through contextual realism, what we talked about. So, for example, our shopping tasks, using local 3D assets, but also through increasing perspectival fidelity. And that means that basically you have the experience of the person you are trying to model. So let's say that if you are trying to study how people will react to animals being slaughtered in a slaughterhouse, if you put the view from the animal, it will be quite different than if you put the view from a person who is actually visiting. That's perspective fidelity. So this first-person perspective of cyclists, synchronization of sensory inputs, and so on, to feel that you are the agent. And finally, we know that there is insufficient protocols and guidelines for technical implementations. So we are working together with our Professor Tuuli, Toivonen, and other researchers using virtual reality in Europe to do this kind of protocols. Our research team is going to produce these open source protocols of development. But we really need to think of how frequently, for how long sessions can be conducted. Can we screen vulnerable individuals? Can we have validation processes? And again, have these issues to increase replicability and generalizability. And these are some references for the papers I presented. Thank you.
Thank you, Silviya, for showing us how virtual reality can be used in urban research. And now we have some minutes for questions from the audience.
Thanks for the presentation. If I can ask, why did you decide to go with this kind of graphic, which is kind of like feels like a computer game, instead of, for example, having a video from actual real nature?
Like a real environment, basically.
Yeah, exactly, yeah.
Well, one of the things is that in the project, we aim to develop things that are applicable to different environments. So basically, so that's first, that if you do a replication of one environment, let's say of Helsinki, you cannot test this in London or in any other cities. So this enables us to produce the method and the blueprint for doing adjustments for future research. Also, we wanted to avoid familiarity. So basically, if you're familiar with some people that are more familiar with this environment may respond differently. Thank you. I think there is one there.
Yes, thank you. And sorry, my bad English. But I'm interested about that. We in here Helsinki have heard of many new buildings. Extra buildings are coming in the central city of Helsinki. Is it possible to use this kind of methodology in research of these from the human point of view, this kind of new buildings, are they, what impact they have?
Yeah, I think maybe that's the whole point, that if we create this methodology, you can test the different elements. So instead of, in this case, we tested vegetation, that you can change the different buildings and you can expose people to these buildings and then test what the effect is. It's just that you have to use different elements to be able to show this. But in our case, for example, they're not like buildings from Helsinki. So maybe in this case is maybe what Mikko was saying, that then you use actual assets from digital twins or other available cities that we can affect this, use to study the effect. Thank you.
Well, if we don't have any other questions, thanks, Silviya. And we can now move on to the panel discussion, where we will explore the central question: can digital innovations make urban mobility more sustainable? I am pleased to welcome our panelists: Laura Ruotsalainen, Professor of Spatiotemporal Data Analysis for Sustainability Science at the University of Helsinki; Tuuli Toivonen, Professor of Geoinformatics at the University of Helsinki; Carlos Lamuela Orta, Senior Scientist on the topics of sustainability, mobility, city, and architecture at the Technical Research Center of Finland; and Hannu Oskala, Voice Scooters Finland Public Policy Manager and former Helsinki City Councillor. Welcome, and I would like to start with a round of introduction. As you introduce yourself, please also provide a brief description of how you define urban mobility, smart urban mobility, and sustainability in the context of your work. Additionally, I would like to ask you to share any paradoxes or inconsistencies you might perceive between these concepts.
I guess I will start. Okay. Yeah, so I'm Laura Ruotsalainen, professor in computer science at the University of Helsinki, and my research area is spatiotemporal data analysis for sustainability science. And then Klavdiia already gave a great presentation of what our research really means. So it means that we are developing deep learning methods to both kind of like provide data and understanding for kind of like mobility cases, and then also how to create kind of like data for decision making for sustainable mobility. And then when thinking about what does urban mobility mean, so it means that people can flexibly go from kind of like their origin to their destination by using different mobility modes and selecting the ones that best suit their needs and wishes for the case. And then when talking about the smart mobility, then we go closely to our research. So how can we then use artificial intelligence and especially kind of like machine learning for then creating the data? So we work with computer vision. So how can we get the cues from the environment to kind of like understand what is going on and how do we move? We work with other also localization methods. So for example, navigation satellite signals, how can we use those to understand how to move? And then, as said, so we work with kind of like optimization methods. So how can we provide data for decision makers to make better cities? So we have, for example, worked with these really complex multi-optimization cases. So how can we at the same time ensure that the traffic flows well in the city and at the same time provide good air quality and also good livability of the cities? And then now when talking about sustainability, so sustainability is also kind of like completely embedded into everything that we do. So we kind of like, as said, look at the kind of like optimization cases from the sustainability viewpoint. But then also, of course, now when coming to talk about artificial intelligence, so then we really have to make sure that when we are making these big models, we make sure that the computation is efficient so that we are not kind of like jeopardizing the benefits that we get from kind of like getting means for making more sustainable urban areas, and at the same time kind of like using so much energy and doing so many CO2 emissions that we are kind of like jeopardizing the benefits.
Yeah, thanks so much, Laura. Nice to always hear you talk. So my name is Tuuli Toivonen. I'm a professor of geoinformatics, a geographer at the University of Helsinki, similarly to Laura, and leading a group called Digital Geography Lab, and this Green Travel project where Silviya was presenting some of our results from. And if thinking about people's mobilities, urban mobility, and our focus overall. So what we are interested in is people's everyday life and everyday mobilities during that everyday life. So really people and groups of people are what we focus on in our attempts to be understanding urban mobility. So as opposed to, for example, transportation optimization, or as opposed to building and designing infrastructures for transportation. So really people and how they move about is what we attempt to be understanding. And the sustainability questions come into place particularly from the perspective of how people use the designed and planned urban space. So the planning ideals, and this is one of the controversies as well, so the planning ideals can be towards very sustainable ways of life, but then how people actually live that planned environment is what we try to be understanding. And how we do it is that we use various different digital data sources, mobility data sources from many different sources, so basically mobile phone data or teleoperator data, application data, and so forth, in order to be understanding how people actually move about and how for example, different changes in the city influence the movements of people. And as we get understanding of people's mobility patterns, people's mobility choices as well, so then we are also able to understand that how sustainable are their choices in comparison to what is offered by the planned system, or how healthy are their choices, so through which kind of environments they move about and have the potential to move about as well. So these are the angles from which we try to be advancing and seeing the urban mobility and sustainability.
Thank you, Laura and Tuuli. So I work at VTT, but I'm also doing my PhD here at Helsus. So maybe my views are more from my PhD research than the official view of VTT. In my research, well, I'm an architect from Aalto, by the way. The urban part actually is more like a planetary urbanization, in the sense that we lived in cities, but they are not walled, like in the Middle Ages. We actually move around globally quite a lot. And I'm sure that in the audience there's somebody who has been abroad in the last few days, possibly. Then the smart part, it's pretty much an agenda. Of course, it's also tangible in the sense that we have data, like we have seen data that can be used to do research. But it's this corporate or political agenda that we have this vision that cities, by deploying these technologies, can be better at some point. And then the sustainability part, it's more like a question mark. Sustainability is, of course, the large narrative that we all lived within. But actually, research shows that everything is unsustainable. So it's more like this leap of faith that we do, that we have research from different things showing how things are not sustainable, but then we talk about sustainability. So it's this kind of philosophical kind of contradiction. And then the mobility part, it's kind of also interesting. We have always moved since when we were gathering berries and hunting in the beginning of humanity. So it's kind of an open question, can we manage mobility, or is something that is so fundamental that it's useless to kind of like constrain? So all those things are kind of like, and in very concrete terms, for example, what I've done is I've looked at cycling data in Helsinki because besides the more sophisticated pattern analysis that Tuuli's work group has done, nobody had looked at what is cycling doing in Helsinki. So I took a look at the cycling counter data, and actually cycling is declining in Helsinki, except for Pohjoisbana, which is a special route. And this is kind of paradoxical because, like Hannu knows and will tell us, there's a lot of policy effort and budget into improving cycling infrastructure. So then why is cycling traffic not increasing? So that's more or less my approach.
I've got my own microphone, which is nice. I'm Hannu. My background is in politics. I used to be also a professional accordion player, but I ain't no more. But used to be a city councillor here in Helsinki, and as the Urbaria nicely put out the information before the elections that I was a former Helsinki city councillor, even though I was a candidate as well. But to go through these like three forms that you asked, like urban mobility, that's, I think Tuuli put it quite well. It's the sort of the everyday life mobility of all citizens in the city. But it's also sort of the triangle of movement in the city. Then it's the politics and policy of the city. And then it's like the infrastructure that is already there in place. So I think all those combine to make the sort of urban mobility it's the environment in which I work in, the policy work for Voi. But then the smart part of it, of course, being a sort of a startup company, we of course have our data wizards in a Stockholm office especially, and we do use a lot of components that can be called smart. We use AI for the logistics part. An algorithm decides which scooters are taken where and when. We also have lots of AI and smart things to do with maintenance of the vehicles and so forth. So that's the smart part. And of course the sustainability part is also really concrete for me in this discussion, because it's the sustainability of the life cycle emissions of the vehicle. And I'm proud to say that we've done quite a lot on that part. By our calculations, we've come 80% down from 5 years ago on the life cycle emissions. And one of the best scooters that we had in Helsinki, there were only over 1,300 trips taken on that scooter before it was moved to retire to Tampere, where it continues to be used now that we have newer models here in Helsinki. So it's really practical things and how we can be most sustainable in our operations.
Thank you. So I have another question to all of you. What are some key questions regarding urban mobility that are currently not receiving enough attention? Who wants to start?
I can be the brave one and start. Again, I'm not an academic at all. I used to be an accordion player. I have to remind you. These people are professors. I'm not. I'm an accordion player. But I think that there is a quiet revolution of urban logistics going on that actually we are not looking at that much, and it's sort of overlooked, at least in the public debate, almost completely. Just a couple of weeks back, there was news in Helsingin Uutiset that HSL, or the city of Helsinki, is going to force the Volt drivers out from the bicycle storage underneath the railway tracks near the main railway station. And I think that's a true pity, because that's a real sign of totally new kind of logistics that has been growing up quite organically. It's smart mobility, it's urban mobility, and it's really revolutionizing all kinds of logistics, not only food parcels. And a real big part of that is actually the sort of the diversification of the vehicles and vehicle classes that we will be seeing here in Helsinki. We are seeing one-wheel drivers. We are seeing now there are actually these sort of smaller but quite large electric cycles with huge amounts of storage space behind that. So how can that kind of transition to more sustainable vehicles, so that not the whole electrification of urban transport would be only electric cars, how we can change the paradigm of electric car into several other forms of diverse vehicles, not only cars or bicycles.
Yeah, I could continue from this. I think that this is a super relevant point and point which hasn't been really studied and it's not really understood. Of course, it's difficult to project to the future, so it's difficult to understand how things will develop in the future. But really thinking about the overall impact of digitalization, like digitalization of our lifestyle. So what does it do to mobility? If we have the different modes of transportation, the different vehicle types, if we have the different services, so Volt, for example, as you gave that as an example, so that people are not anymore going to restaurants, but they are staying home, and the courier is actually the one making the movement. If we are ordering more from the shops, if we are more consuming, for example, entertainment at home, and so forth, so how does all remote working, of course, is a big thing. So how does all of those changes change our mobility patterns and, of course, the modes as well? If we more move for recreation, for example, than for the urgent need, and how that will change not only like the vehicles, but also the whole spatiotemporal patterns of movement, that where people actually move about, like whether they come to the city center and whether that's even a relevant question anymore in the future is I think, one super important thing there. Yeah, I had other things in mind, but
okay.
maybe you want to jump in.
And of course, from a policy perspective, how does the city think about these newcomers to the field? Are we going to ban those Bolt drivers from the self-built warehouse underneath the tracks, or are we going to facilitate them somehow? Are we going to facilitate the change or try to put a stop to that?
Yeah, and I think that is as well a relevant point from the perspective that who do we actually pay attention to when thinking about urban mobility, in the sense that now in transportation planning, where there is space, starts from safety perspective, which is of course very important, that there's like a different lane for everyone. So there are car lanes, there are the public transportation lanes in new areas in Viki, for example. You have very broad bike lanes, which is fantastic for the bikers, and then you have quite broad lanes for walking or pedestrians as well. But what that leads to is that if we want to be separating all the modes, so when the modes become more and more, so we just need to be reserving more and more space for those different modes. And somehow I guess that in Copenhagen, for example, they have already noticed that the bikers don't fit to the streets, that actually we have to be somehow making it like us more tolerant of these different new modes and have more rule-based system probably. And then also start to be paying attention probably to the comfort of the mobility. So if and as we really have to be moving to more carbon neutral direction, many of the structures that we are actually at the moment implementing are not taking us to that direction. So as Carlos was pointing out, biking, even if there's huge amount of investment on biking lanes at the moment in the city of Helsinki, for example, so still bikers are not taking advantage of that yet. So people are not changing from unsustainable modes to more sustainable modes, at least as much as we would like to see. So how should we make that transition is, I guess, a key question.
Laura wanted to add something.
Thanks, and I could also continue with the modes discussion, because something that I was hoping for so much to kind of like solve many of the mobility problems was the mobility as a service. So not only thinking that there's a variety of modes, but how they are really connected, so that kind of like a person doing the kind of like moving doesn't have to think about which kind of like modes do I select, but thinking that I'm going from point A to point B, and then I will just flexibly change kind of like the modes while I'm going. So that's definitely something, and I understand there's also quite big economical issues, so how do we kind of like somehow synchronize the kind of like costs of different mobility modes and things like that related. But then also you referred to the kind of like safety of mobility, and I think that's a big issue also. So there's still in the world 1.2 million people dying yearly, and kind of like 90% of those are due to the human driver error in road traffic, and those are due to kind of like people using smartphones while driving, and that's definitely a big issue, and I don't think it's getting any easier in the kind of like very near future. And then still the third big issue that is not yet solved is the accessibility of different mobility modes, because there's a huge group of kind of like people still who don't have their own cars, and they can't drive a scooter scooter or any other the good mode. So how can we kind of like take care of especially these last mile kind of like transportation and mobility issues?
Thanks for the question. I think most everything is research. I don't think there's really that much of a gap. For example, the thing with the food delivery platforms has been researched by our colleagues at the University of Helsinki from the experience of the riders themselves and how the algorithmic platform is a quite unhumane way of working. And of course, it's kind of funny that this, which is a digital thing, it's actually based on people working. Actually, not just any people, but actually most of them are migrants or racialized guys who are freezing in the streets of Helsinki driving those electric scooters, which is kind of, you know, it's funny for me because at the end the smart relies on actually a person having to do a physical work. That's kind of interesting. But perhaps when we talk about mobility, what I would like to hear more about in the discourse is the part about flying, because I think it's really increasing all the time. And for example, if you look at the data in Helsinki since the pandemic, one mode that has gone up more than any other is the Suomenlinnan lauta, the ferry to the island. And that's basically tourism. And that's like plus 20% from pre-pandemic levels. And it's relatively relevant that I bike to Otaniemi to work, as I do, as a good citizen, instead of driving my car. If then I go to Bali to surf every other year or every year or whatever, it's relatively relevant in terms of emissions, which is also a very typical definition of sustainability, is this carbon tunnel that we only look at emissions and not at other things. So yeah, so I would say bring everything together, not just, don't stay on some kind of nice thing like a bike, which is super nice, but it's not the whole story.
Tuuli?
Yeah, I would like to continue from this one, the flying part, not as a phenomenon as such, but from the smartness perspective, that if one thinks about making a trip abroad and the mobility choices that one has. So of course there often are, like Finland is a bit of an island if thinking of going to Europe. So it's difficult to be moving about in sustainable modes. That's one limitation, of course. But I think that one of the limitations clearly is not having enough information, not having easy tools to be planning for your trip. If you would like to be going to Barcelona with sustainable modes, or with any mode, you would be finding the flight information in 1 second and have various alternatives served to you, prices provided, routes provided, timetables provided, whereas for everything else you don't have that. And I think that that's a place where we really could be improving through the smartness, so through providing tools and data for people to be planning their trips better. A sustainable choice. But of course, for real, we just should be reducing our mobility in order to be meeting the carbon targets.
We have little time, but if I just answer to have some kind of conversation, that's super interesting. That's something that we work with all the time for public transport at VTT, because there is this idea that if we only would have a better ratio pass this up for moving around, then people may use public transport a bit more. But in reality, the ratio pass of today is awesome compared to 20 years ago, and the number of users of public transport are going down. So there's this idea that if we only give better information to decision makers in the city council or to the consumers, there'll be this rational choice that, okay, I can do this. And I'm very critical against this, and also the materiality again of the thing. I have planned to go to Spain, I'm from Spain, by train. And I haven't done it because it takes forever. And I have kids. I mean, taking away the information part, I've done my homework and I know the route and my colleague has done it and I know how to go about it. But it takes 3 days with kids in a train, and going by airplane, it's 4 hours. So, I mean, it's not, for me, it's like, I'm sorry, but I'm just not ready to do it. I feel that I could try it, But it's not like, and so I think there's this feeling that we are a bit paternalistic that, oh, people are driving cars around. Well, cars are an amazing thing. Of course, they are destroying the planet, but it's amazing to drive a car. And also one thing is that, hey, by the way, cars have more digital, smart technology than anything else nowadays. You go into a modern car, your phone gets connected immediately, you have your whatever playlist, it knows your name, whatever. It's like, that's also smart mobility, but nobody wants to say, hey, cars are actually smart mobility. They're also digitized. So, yeah.
Okay, I would like to switch a little bit the focus and to ask you a question about like security issues. And I would like to ask to Laura, do you think that some of these new smart mobility systems and the digitalization of our traffic infrastructure could contribute to making our cities more vulnerable to cyber attacks and other forms of hybrid warfare and cyber terrorism?
Well, there's only the sad answer that definitely yes. So more kind of like we rely on techniques, the more we need to protect. I think it's kind of like a continuous run, like in all the, for example, computer programs, that whenever we have something that is very critical and important for the society, we always find someone who is trying to harm that. But I would say that kind of like while we are aware of that, we can also then, of course, develop measures then to protect. But it is definitely correct. So, for example, when we are thinking about autonomous driving, where kind of like the vehicles have to be using some kind of like infrastructure in the environment, they have to be sharing their kind of like location and knowing where everyone else is. Definitely there are many vulnerable places there that can be attacked, but also that can be protected.
And Tuuli, do you believe that there are ethical considerations in collecting and using urban mobility data that we need to be more mindful of? For example, concerns about privacy?
Well, certainly we have to be mindful, but I think that we are very mindful at the moment. And to some extent, I feel that we might be even like overly mindful to some extent, meaning that we are not able to plan and particularly follow the usage of the urban mobility systems as well as we could if we would be using all the data that there is available. Still, of course, anonymizing the sort of individual data out. But for example, the fact that we discussed with Hannu on the coffee break earlier, that what I learned is that all the Alepa bikes have GPSs, and those GPS data is not available for research, for example, and we don't even know that it exists. Also, for example, the transportation card data, when it was introduced, it was very sort of anonymized so that we couldn't be tracking where people travel. But that, of course, leads us to be planning systems which we can't really follow that how they are being used and to be optimizing them with the information. So I think that there's a thin, like, it should be more carefully considered that what's the benefit of using the information, more but mindfully to be protecting everyone's privacy.
Do you have anything to add? No. So Carlos, I would like to ask something to you. What do you imagine the urban mobility landscape will look like in 10 years, and what should we do preparing for it?
That's a kind of difficult one. I think that the future has been much more slow to arrive than we have always thought. So I think that the best research is saying that what we are seeing now will continue to play out. So a little bit more electric cars, a little bit more like public transport becoming maybe more rail and less buses. Buses are going down all the time. Micromobility, the emergence of micromobility, Hannu knows more about this. It's been also, well, yeah, e-scooters are a new thing, but I don't know if micromobility only e-scooters. I don't know if anybody knows. Hannu says no. Maybe you want to continue about the future, no? Well, I mean, I think it's just going to play out slowly. One thing that we should perhaps try to get ready as a country is critical reliance on materials and energy. So, for example, now electric cars are coming from China. we cannot produce electric cars in Finland because we don't have all the components required. But also petrol. If fuel would not flow to Finland, I think after whatever days it takes to run out of what we have, we would be in a very dire situation. And in that sense, cycling is a good kind of like way to prepare. If you can do your daily life with a bicycle, maybe you're a bit more resilient for the future, maybe.
Thanks. And Hannu, beyond reducing emissions, how do digital mobility solutions integrate into wider sustainability goals? Beyond reducing emissions, how do digital mobility solutions integrate into wider sustainability goals?
So how do the digital solutions connect with the wider sustainability goals? Well, that's a good question. I think that the most advances that we made regarding sustainability, they are quite stupid solutions. They are better maintenance, for example, of the vehicles. But of course, the maintenance is enhanced by AI that knows which vehicles to maintain and when and where. One fun example actually comes to mind, which is that we can see when the scooters are toppled or upright. And at some point we noticed that in a previous models of ours, the structure was starting to break on some of the e-scooters. So we had to fix and put a fix kit on those. You can see them in Turku, in Finland, for example. And what we found out that if the scooter had been toppled during its usage history for more than 20 times, the average on the breakage went up significantly. So we could use the data to enhance the life cycle of the e-scooter quite a lot.
Now I have a question to all of you. Do you think, have there been instances of resistance from companies or the public regarding the implementation of smart mobility solutions? And if so, what are the potential reasons behind the lack of trust?
Have there been any with e-scooters? Nothing comes to mind. So that's sort of my main work is done in that arena. How would I put it? Of course, we have the reasons for that is of course mainly how we came to be the first new form of transportation for like 8 years on the streets. We came quite uninvited, and for example in Helsinki, it sort of broke the nice structure the city had, where the city had all the control for all kinds of mobility. But then we have a disruptor, companies that come in uninvited and are not controlled by the city. And again, that is a policy question also for the city, how to respond to that kind of new things that come to your streets. And I think that all the benefits that come from these kinds of new forms of innovations also on the digital front of these forms of mobility come if only the cities are also open to at least some amount of risk taking and also relaxing the controls that they have. Because if you want to control everything and if you don't want to take any risks, then you are not going to see any innovation. But we are seeing that playing out every day on the streets and in the city council as well now.
Yeah.
Yeah, I could also reply that I think that the kind of like the biggest sustainability benefits we get from kind of like autonomous driving in the future, but not in the way that all the private vehicles would be autonomous, but in the way that we would have kind of like a very large autonomous public transport kind of like fleet, but also all the kind of like the private vehicles would be shared one, like in the Klavdia's presentation was kind of like discussed. So thinking that then we would really have kind of like less vehicles, more green areas, and kind of like sustainable benefits from that direction. But also I would assume that kind of like the vehicle manufacturers maybe don't really agree with this viewpoint, so that might be one of the points of resistance also.
And if I may continue, so I'm not sure whether I answer fully to your question, but in terms of resistance, so thinking about how politicized, how do you say it? Politicized. Yeah, anyways, you get what I mean. The transportation discussion is at the moment, so that's quite challenging. I think that nobody really dares to be questioning the role of car in the urban transportation system, or some do, but still when you do that, it's considered ideological, even if from many perspectives, actually we should be thinking from sustainability perspective, the ways how we move about in new ways. And I think that like we all, or at least I fall on that trap. So now, for example, when the scooters came to the streets this spring, I was annoyed by them being there all around. And then I started to be looking at how much they actually take space in comparison to the parked cars, which took like 200 times more space in the vicinity of in my vicinity in comparison to those. And still I paid attention to the scooters. So in a way, like we are so used to the car orientated society that making a change is really a difficult thing, and there's a lot of resistance from that perspective.
Yeah, I think that the one good example is the bike lash or the reaction against cycling. You could say that that's one kind of resistance, but also I think that it's a bit too easy to say that people are resisting because they don't know any better. And again, that goes back to this paternalistic way of thinking. Helsinki has okay cycling infrastructure, has had it for 15 years, the time that I've been here. And of course, if you don't want to cycle, it's not like, no amount of new data, however cool research we are doing, will tell people that it's for your own sake that you should cycle. So it's a bit like, the other thing about, for example, electric cars is like, well, I guess anybody would like to have an electric car. If you are going to have a car, why not let it be electric? Different stories, can you afford it? And also with e-scooters, in my research, where I make observations of the users in Helsinki, e-scooters are the least gender balanced mode in the sense that it's a majority of male, and I think it's 60 or 70% are men. So there's also all these ideas that we have about ourselves. Do I identify as a e-scooter user, or as a cyclist, or as a public transport user, etc. And that culture is very, very difficult to change. Helsinki will never be Copenhagen, not because we won't have the bike lanes, which we will have at some point, but because we don't have the history where cycling is normal and is part of life and everybody does it, and my mother did it and my grandmother did it and whatever. We're coming from a different point. So in that sense, you cannot avoid that people resist, because people just come from where they are coming from. That's culture, basically, which is real. It's,
Well, if you don't have anything to add, I will leave some time for questions from the audience. Here we have one.
Testing, okay. Yeah. I wanted to ask about this mobility as a service, which you talk about. So I think like this Vim app, which is being developed, but it's been failing now, and very less number of people are using or know about this term mobility as a service. So what are the reasons like why people are not going to this mobility as a service, which everybody knows has benefits? That's my first question. And second question is on the bike thefts. So like recently, like everybody encouraged me to have a bike. I had a bike, but then it got stolen the other day. So why can't we bring some policy frameworks to discourage bike thefts in Helsinki at least? Because from year on, there have been a lot of bike thefts. So thank you so much.
Yeah, I don't know if you, Hannu, know more about the mobility as a service. So I was present when the kind of like the system was established in Finland, and there was a lot of discussion. And based on my understanding, that the kind of like the case was that there were kind of like the different mobility modes were supposed to be somehow synchronized. So the taxis in Helsinki, which kind of like created this huge taxi reformation, and the buses and all these different systems. But to be honest, I don't know what happened. I've been just following from the media also the discussion that for kind of like slowly, kind of like the development stopped, and then the company even stopped. But maybe Hannu has better knowledge for that.
I happen to know something. I used to work a bit with Wim as well several years back. But it boils down back to basically the car-centric nature of the whole society. It's not about only the infrastructure. It's not only about the applications. It's about, for example, the tax exemptions. So if there is a company, let's say Nokia, that wants to buy full car benefits for its all its employees, it can do that easily. But even though the whole package that they were offering was the same euro value, they couldn't get any tax reductions on that. Because the tax authority just said that, no, this is understandable, this is a car. You can get a tax exemption, it's an easy way. Yes, this is a car. But this is a service package, what is there? Taxis and public transportation, go away. So there were really a lot of structural things behind the demise of Vim app and mobility as a service in Finland. And of course also going back to the loss of control and the risk-taking from the public transport sector side. So the HSL wanted to have its brand at the forefront when tickets are sold, and not the brand of some whim or something else. So it's also about these kinds of more cultural issues and policy issues related to regulation and hallinto of all things than just if the idea is workable or not. In a perfect world, it would have been probably a good idea. Bike thefts, well, that's the policy of Helsinki, and it's a total mystery why they are not doing their job at all.
Tuuli?
Yeah, maybe still for the mobility as a service. So I think that also for like another hindrance there, I guess, was the pricing also for individuals. So not that it would have been super expensive in comparison to owning your car and so forth, but if, like, I think that in this car-centered society, you don't really count the cost of a single car drive, so that you would be thinking that how much does it cost to buy a car, how much does the maintenance cost. They go from like different section of your budget, and then when you compare only like one trip price, so that seems very expensive to be having that kind of shared car that was included in there, for example, or the price overall. So I think that the pricing felt high, even if probably it was not. But I wouldn't like to be giving up that it couldn't be working. Like even if earlier time the implementation didn't work out, so I do see a future where that kind of approach could be implemented and should be implemented to be having more sustainable mobility system in the cities all over.
Hannu?
Just a short point I have to add. I think that what Tuuli mentioned about the cost, I think that like the marginal cost of mobility is really it's a key part of every change we are going to see, and we have to put a marginal cost on owning the private car and using your own private car. Without that, we are going to be in some sort of a hellscape, especially with the autonomous vehicles. If it's cheaper for the autonomous car to go around the block than to be parked, then it's going to go empty around the block. And we're going to have a total traffic jam of just empty autonomous cars waiting for their owners.
Do we have any other questions?
Well, I actually have a question. I'm interested, has it been studied whether these new forms of transportation, such as micromobility, and maybe also, say, robot taxis, autonomous vehicles, if they actually increase sustainability in the sense that considering the people who actually use them, like, for example, say these e-scooters are the users, basically people who would otherwise use other sustainable methods of transportation, such as cycling or walking, or is it actually car users that then use these solutions?
That's a very good question. It's been studied, and there was a very clever experiment design at Berkeley, where they had this human chauffeur, so driver, that would work as a robot taxi. So you could just tell, suppose you are the chauffeur, okay, Jussi, go drive my car to Prisma and pick up this parcel. And then Jussi, drive me to Helsinki downtown, but because it's difficult to park, drive away while I'm in a concert and then come back to pick me up. And the results were that it increased car use a lot. And of course, that goes back to the rebound effect, that when things get easier to use, usually you use them more, so it usually eats away the efficiency gains. That's a quite general principle. I don't say that okay, perhaps if you switch from driving your car to using an e-scooter, that's a cool, good decision. But also one thing is that in transport research, we see that new modes don't substitute the old modes. So I start walking, then I also cycle, then I also drive my car, then I also take an airplane to cycle in the Canary Islands, because it's nicer to cycle there, and then it goes like that. So it's, yeah.
Yeah, but I would like to add that I think it's about policy making. So if we really think that we want to make a sustainable kind of like world, then we really have to make also the decisions and not to let kind of like each individual choose that, do you want to have your own private automated taxi, but to think about how to organize the whole traffic and decide that kind of like, then the vehicles are shared or something else there.
Please go ahead.
Well, I would like to just echo on what Laura is saying, that like if we think about us as human beings, so we are busy, like too busy, and the busyness leads to unsustainable choices. Even if we would like to do sustainable choices, we still have to choose the 4 hours instead of 3 days to go to Barcelona, even if we didn't have the kids. Like still, like we are busy, we are lazy, and comfort seeking. So, and the planning should be starting from those points, not to be providing us all the opportunities to be choosing something which is even more comfortable. Like that's the starting point. So if we want to be really making sustainability choices or sustainable society, I guess that there has to be some stick on top of carrot as well, unfortunately.
And I'd like to give my answer as well, because this is, of course, one of the first questions that I get when meeting every politician I have met this year. So you are only replacing walking. That's basically the argument that I get. Well, let's think about downtown Helsinki. Actually, we have these sort of studies that what we are replacing or what modes of transport we are replacing, but that same question is never asked for the trams. The trams replace walking as well. All the city bikes replace walking. Almost all of the bicycles replace walking. So in a way, once again, the new form of transport is asked different kinds of questions. What we can see from our user survey data, which is of course only our user survey, but we had only over 1,000 respondents every year in Finland alone, is let's say 15% of the trips would have been taken with a private car. So we are replacing some of those. But I think going back to the point that we actually should be looking at a sort of multimodality and diversification, I think the more important question is, or the answer is that actually 43% of our users say that they have either ended private car use or they are using their private car significantly less because of e-scooters. Not that every trip is taken on e-scooter, not that every trip is taken on the private car, but they are diversifying their modality choices. And I think that's one of the key things to get rid of the car ownership paradigm towards sort of a much more multiple choice world in which public transportation and micromobility are much larger part of the mix.
Thank you. If we don't, we have another question.
We'll ask about the city bike system in Helsinki. We have here a very good system, but it's, I think, a little old-fashioned. I have used it many years. It cost only 35 euros a season. How it is possible to develop that system we already have?
Well, there's been a new tender out, and there's going to be a new system next year. And there's going to be decisions in the city council in Helsinki, Espoo, Vantaa, and I think Kirkkonummi in May and June this year. So we are going to see the new ones. The last was for 6 years, and the next one will be for 6 years to come. And I think this is really interesting to see, because 10 years or 6 years is an eternity in urban mobility, or at least in micromobility. So it's the current system feels antiquated now, and I bet the new system will feel antiquated in 6 years. But for 35 euros, that means that it's subsidized, and it's heavily subsidized, and that is actually the reason why we are not seeing any market-based bicycles in Helsinki anymore, because it's just impossible to compete with 35 euros for the whole season, when that's actually basically the price of 1 month service for a floating modern e-bike.
Well, that's a good question, because in reality things evolve kind of by themselves. Like entrepreneurs come up with new services, and companies come up with new products, and then the consumers choose, and it's not like we can develop it so much, but it's more knowing that it will develop somehow, slowly. With cycling, the thing is that it's an ideal that we try to keep alive with kind of like, it's like in the, how do you call that? Like in the emergency room, and we are putting oxygen to the bicycle, because we like bicycles so much. But bicycles peaked around 100 years ago, because around them there's all kinds of better options, or options for lazy humans like we are. and a good question is like, is an e-bike still a bicycle, or is it something new? Is it a different species that maybe will still develop, because it's so much nicer to use and you have more range and whatever? And I think it's not very clear if the new system will be electric. Apparently, it's very unlikely. I don't know what will happen, but that will be interesting. How the policy, the well-meaning policy, will it actually kill a more, say, organic development of the micromobility ecosystem, maybe?
I think it's fair to say that currently the systems planned and tendered out in Helsinki, they are effectively, at least if not killing, they are driving out the marketplace. And you can have arguments of if the marketplace is a good thing or bad thing, but you have more control without the marketplace, but the market has its benefits, for sure.
Thanks for this interesting discussion. Now we have run out of time, so I would like to thank you all to participate to this event. I would like to thank to our panelists and also to our researchers who gave their presentations. And I would like to thank all the audience who participated today. To stay updated with Urbaria's work, you can visit our website and follow us on Blue Sky, Facebook, Twitter, and LinkedIn. So we hope to see you at Urbaria's future events. And thanks again, and I wish you a great rest of your day.